electric battery.
Yeah. So, what do you know about the electrical battery?
I don't know anything, I swear.
Sources told us that you were seen at the University of Bologna, where Galvani first theorized about electricity, and we saw you checking out the first battery.
I mean, I was there, but it was only one time thing.
What about the electrodes that you have?
Electrodes, these are electrolytes.
No, the electrolytes are the solution that the electrodes are immersed in. We saw you with the electrodes. The two plates are rods.
Oh, that's just from an electrical cell, which is two rods called electrodes immersed in a solution of electrolytes to create a simple circuit.
And that part of the electrode outside the solution, what's that?
No, that's the terminal.
Oh, I see.
Mm.
Okay.
Yeah.
Electric current.
So, we searched your bag and we found this. What does it mean?
That's a sign for a battery. The positive is the longest side and the negative is the smallest.
I see. So if you help us solve this problem, we might be able to let you go. So, a steady current of 2.5 amps flows in a wire for 4 minutes. How much charge passed through any point in the current?
So, if the formula for electric current is charge divided by time, then to find the charge you would have to do current multiplied by time, which is 2.5 times 4 minutes. 4 minutes is 240 seconds, so that would equal 600.
I see. And I've heard that electric current has been measured in a word called amperes. The conventional current, what do you think about conventional currents? Is it positive to negative or negative to positive?
Positive to negative?
I see. And negative to positives are electron flows, correct?
Yes.
Ohm's law. Resistance and resistors.
Oh no, that wires can't be perfect, right? So they have to have a little bit of resistance.
Yeah, that's right. Resistance is measured by V equals IR, or Ohm's law, and calculated in ohms.
Resistivity.
I found this paper in your bag. What do you have to say about it?
This is the formula for resistivity. That's when resistance value is multiplied by the length of the wire divided by the cross-sectional area. And if the length of the wire increases and the area decreases, then the resistivity goes up.
Okay.
Resistors in series and in parallel.
What do you know about the circuit conspiracy?
Nothing, I just love resistors. Like, you know, the good old series resistors, which are resistors connected end to end, and parallel, which is where the source splits up into two branches. I know nothing.
If you really love series that much, then what are the formulas?
Oh, well, for series, it's adding up the R's, and for parallels, it's adding up the inverses. So for a series with 4 and 3 resistors, it would be 12 ohms, while in a parallel with 3 and 4 resistors, it would be 7 over 12 ohms.
EMF and terminal voltage.
Yes? Oh, really? Okay, thank you. We've just received word that you are working for the infamous Archibald McCarg. What do you have to say for yourself?
Okay, I'll tell you everything. You made me do it. The source of electromotive force is a device such as a battery that transforms one type of energy into electrical energy. He made me do it.
And what about the internal resistance?
Every battery has some internal resistance represented by R, and when there's no current drawn from the battery, we measure terminal velocity by EMF minus IR equals V absolute.
Kirchhoff's rules.
Okay, I've just met with my consultants, and we've decided that if you can name some of Kirchhoff's laws, then we can produce your sentence.
Okay, Kirchhoff's first or junction rule is that at any junction point, the sum of all currents entering must equal the sum of all currents leaving, which means I3 equals I1 plus I2. And Kirchhoff's second or loop rule is the sum of all changes in potential energy around the closed path of a circuit must be 0, which shows that there can be voltage drops, which is the decrease of voltage between two ends of a resistor.
Thank you very much.
Solving problems with Kirchhoff's rules.
So how do you use Kirchhoff's law to solve problems?
Okay, first, in all the junctions, apply Kirchhoff's first rule about side junctions, I3 equals I1 plus I2. Then apply the loop rule to the second junctions, to the loops, make up new rules. Then write down all your algebraic equations, solve equations algebraically with unknowns, plug one into the other, and then you solve that.
Okay.